Hello again, and welcome back to the world of awesome Algebra 2 notes with Miss Faust. Today we're moving on into our rational expression unit, and remember, rationals are just rational expressions are fractions plus variables. So really all of this, if you have ever learned anything about fractions, all of that's going to apply now as we work with rational expressions. So you looked at graphs in class last time, and now we're going to start looking at how we can do some operations with rational expressions and then simplify them. So today we're going to sort of be building the foundation for that. Our essential question is, how do you find a least common denominator and excluded values for rational expressions? We're going to work backwards. We're going to start by looking at excluded values. So when we think about this, what we want to remember is that we're really working with fractions. So hopefully somewhere in your mathematical past you learned that when you have a fraction, your denominator cannot equal 0. If your denominator equals 0, bad things will happen. So when we're looking at rational expressions, what that means is we have to take our denominator and exclude any values that make it 0. That's where the asymptotes came in the graphs. So if you just had 1 over x, then the excluded value, the part of the domain that doesn't work, is x can't equal 0. So you can find a value for 1 over x for anything but when x is 0. So all you're doing when you're looking for excluded values is you're looking at the denominator and you're finding the values that make it equal to 0. So some examples of that would be if you had x plus 2 divided by x plus 2 times x plus 3. So this is a really simple example of a rational expression. It's already factored for you. You'll see in a minute why that's so important. But what we do is we look at the denominator, and that denominator is what can't equal 0. So what we can do is we can say x plus 2 times x plus 3 can't equal 0. Well, if x plus 2 times x plus 3 doesn't equal 0, then this can't be 0 and this can't be 0. So each factor of the denominator can't be 0. So that's how we take it into the rationals, is we look at the factors and we set each one not equal to 0. So we say x plus 2 is not equal to 0, x plus 3 is not equal to 0. Well, we solve these just like algebra 1 equations, so x is not equal to -2, x is not equal to -3, and those are the two excluded values for this example. Okay, so if you put in a -2 here, you'd get a 0 on the bottom. You'd be multiplying by 0 in the denominator, world would end, or something like that. I don't think it'll really end, but you know, I can be a little dramatic. Example 2. So if we start with x over x cubed minus 4x, well, in order to look at that denominator, we want to factor it first. You want to get in the habit of always just factoring rational expressions. When you see them, factor numerators, factor denominators, and go on from there. So what I'm going to do is I'm going to rewrite this one in factored form. Factor me. Sorry, I was just speaking on behalf of the rational expression. So if we look at this, we have a common factor of x in both of those. So if I take an x out of x cubed, I get x squared. If I take an x out of 4x, I get 4. Well, that can still be factored again because x squared minus 4 is a difference of squares. So remember, that means this is like x squared minus 2 squared because 2 squared equals 4. So that can factor into x plus 2 times x minus 2. That yellow handout I gave you last semester will still be really useful. I hope you didn't throw it away because you know how rare yellow trees are. But it'll help you with factoring things like this. So we get x plus 2, and x minus 2. That's our denominator. So again, we take our denominator. We think about the factors of our denominator. So we have x plus 2, and x minus 2. We only care about the denominator when we look at excluded values. 0 can be divided by something, so you can have 0 apples and share them among 10 people. They all get 0 of them, but it's okay. So it's not the numerator we care about, it's only the denominator. So that's what can't be 0, which means each of the individual factors can't be 0. So that one's already solved. X can't be 0. X also can't be -2. And X can't be +2. So for this particular problem, the excluded values are not equal to 0, -2, and 2. And again, those come from the denominator. Okay. Next thing we're going to look at is how we simplify rationals. And again, this is something that you want to think about because you're going to want to do this sometimes before you add, subtract, or multiply or divide fractions. I'm sorry, rationals. Well, fractions or rationals. So just to go back again and think about fractions, if you have 6/12, hopefully you see that and right away your brain goes, oh yeah, that's 1/2. Well, that's because on top you have 6 times 1, and on the bottom you have 6 times 2. So the 6's cancel, and you're just left with 1/2. If you had something like 10x squared over 2x to the 5th, your brain wouldn't immediately think of how to simplify that, but you can look at that and you could examine it and you could say to yourself, oh, that's right, 10 is 2 times 5, and I have x squared there. 2 is 2 times 1, and then if I think about this x squared versus x to the 5th, well, if I had x squared and x cubed on the bottom, those two together give me x to the 5th. I'm separating them out because then I can use my magic sound effects. My 2's cancel, my x squareds cancel. I'm left with a 5 on the top and 1 times x to the 3rd on the bottom. So that simplifies into 5 over x to the 3rd. When we simplify rational expressions, we're going to do the same thing. But the first thing we're going to have to do is we're going to factor our numerator, that's the part on top, and our denominator, that's the part on the bottom. Numerator, denominator. Okay, and then once we do that, we cancel out common factors. We still need to keep those factors in mind because those are still going to give us excluded values from the denominator, but they'll just simplify our problem a little bit. So for example, if we have x plus 4 divided by x squared plus 6x plus 8, so what we need to do first is factor. So we look at the top and we see there's no exponent on the x, there's no common factor between those, so that's going to stay x plus 4. On the bottom I see this 8 and this 6, I see it's something squared, nothing in front of the x, so I'm going to try and think of two things that multiply to 8 and add to 6. Think, 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 think. Did you get 2 and 4? You were right. X plus 2, x plus 4. 2 times 4 is 8, 2 plus 4 is 6. You may need to make boxes to do these, that's fine. I just don't want to take the time in the video to show you that. So whatever strategies you use to factor gets us there. We stop and look at our excluded values real quick. And I'm not going to go through all the steps for that again. I know I need my denominator and I need to make each of those equal to 0. So if x plus 2 is not 0, I know x can't be -2. If x plus 4 is not 0, I know x can't be -4. Those are my two excluded values. And then finally, so here I'm trying, simplify. Sorry, I haven't done this in a while, can you tell? So we look now, and notice here we have x plus 4 on the top and x plus 4 on the bottom. So what we can do is we can cancel that. The one thing you want to be careful of is that on top you're going to be left with a 1. So when we're done with this problem, we're going to have 1 over x plus 2. It's our simplified answer because we have this 1 left and the x plus 2. So our answer is 1 over x plus 2 with those excluded values. Okay, so again, factor, cancel, look for excluded values. Example 2. Shall we do that one? Yeah, we'll do that one. 2x squared plus 10x over 3x squared plus 15x. So this kind of factoring is what still messes people up. I think they just forget that they can take out least common or greatest common factors. So if I look at the 2 and the 10, both of those have a factor of 2 in them. If I have an x squared and an x, both of those have a factor of x in them. And then I say to myself, well, if I have 2x squared and I take out 2x, I'm just left with an x. And if I have 10x and I divide that by 2x, 10 divided by 2 is 5, x divided by x is 1, so I get 2x times x plus 5. On the bottom, 3 and 15 are both divisible by 3. There's 1x in both of them, and then again 3x squared divided by 3x leaves me with x. 15x divided by 3x, 15 divided by 3 is 5, x divided by x is 1. So I get 2x times x plus 5 over 3x times x plus 5. I think about my excluded values while I'm here, because those come from my denominator. So before I get rid of anything, this one right here tells me x can't be 0. This one right here tells me x can't be -5. Again, you set up those equations. You could do 3x, x plus 5 not equal to 0, break it into factors. The 3 doesn't matter. If you need to see another example, go back in the video, ask me in class. Now we get rid of common factors. X plus 5 and x plus 5 cancel. The x on the top and the x on the bottom cancel. And we're just left with 2/3. So our answer for this one is 2/3 with those excluded values. And the reason the excluded values are still important is if you were going to graph this, if this was a function and we started with this, our function would just be a line at 2/3, but it'd have holes in it when x is 0 and when x is -5. So those are the big ideas behind simplifying and finding excluded values. Now we're going to use those to go on and look for least common denominators. Now that we've set ourselves up, we've learned how to simplify, we've learned how to exclude values. The last thing we're going to look at today is how to find a least common denominator. And I'm going to be abbreviating that LCD as we go through. Not talking about TV screens, I'm talking about least common denominators. So what you do is you factor everything. You're going to have two rationals, you're going to factor numerators and denominators. You're going to compare the denominators, and it's just the denominators that we really care about when we're looking for least common denominators. And then what you do is you look for what's missing in the alternate expression. The idea is that you want the denominators to be the same, so you look for the part that's missing, and then you multiply that by the other expression, so both on the top and the bottom. And that'll be really clear once we do it once or twice. You've done this with fractions, so it's going to start to sink in pretty quickly. And then the least common denominator, or the LCD, if you're ever asked just for that, it's just the factors of both denominators, one copy of all of them. You never want to repeat them. But that's what you do when you're looking for the least common denominator. So let's look at an example, because I know right now you're just confused. You're going to jot down any questions you have over here, though, and you're going to ask me in class next time. And in the meantime, we're going to do some examples. So what we've got, as soon as we get this, and the word notes, and a couple of question marks. So find the least common denominator of the rational expressions. So example 1, and you're always going to have a couple of rational expressions in these. I'm going to do some examples with just 2, just to keep it simple. So our first expression is -2 over 3x minus 15, and our second expression is 3x over 4x minus 20. So what we want to do is we want to think about factoring each of these. So when I look at this one, on the left, 3x and 15, well, we did one like that already. There's nothing on top that comes out, but I can take out a 3, and I get x minus 5, because 3x divided by 3 is x, and 15 divided by 3 is 5. Over here, I get a 3x on top, and then on the bottom, 4x minus 20. So both of those have a factor of 4 in them. and an x minus 5. So now when I want the least common denominator, I want one copy of each factor. So I want the 3, I want the x minus 5, right, because those come from here. I want the 4. I'm not going to put another x minus 5. I already have it once. Putting it twice makes it no longer the least common denominator, but one of the more complicated ones. So now here's where you have to think a little bit. Again, once we've got the LCD, now what we're going to do is we're going to rewrite these with that least common denominator. So looking at this first one, notice that the 4 is the part that's missing over here. There's no 4 in that denominator. And then you also might notice that the 3 is the part that's missing over here. So what we have to do is we have to take this problem, oops, I better write the original problem in black again, -2, 3x minus 5, 3x over 4x minus 5. So what I want to do is, on this right side, I want to multiply by 4 on the bottom. But if I multiply by 4 on the bottom, in order to keep my problem the same, I have to do the same thing to the top. I always have to do the same thing to the top and bottom of a fraction. So I'm going to multiply both parts of that one by 4. This one, it's the 3 that's missing, so I need to multiply by 3, but I need to multiply by a 3 on the top as well. So I'm not changing my expression. So now I can just simplify that a little bit. I get -8 over 12 times x minus 5 and 9x over 12 times x minus 5. I have the same denominators. That was my goal. So since my denominators are the same, I am happy. Okay, so we're just factoring, multiplying by missing factors. We'll do one more example together. You probably have room on the other page. I just let that one take up a lot of space for some reason, but that's okay. So this time I'm going to find the LCD again. So if I have, and I'm going to rewrite both expressions with that LCD. So my first one's going to be x plus 8 over x squared plus 11x plus 24. My second one is going to be x over 2x plus 6. So again, I start by factoring. So let me just keep using different colors because it's fun. Maybe you're already thinking two things that multiply to 24 and add to 11. Nothing to factor on the top. On the bottom, 8 and 3, I believe. X plus 3, x plus 8. Here's a hint. If you have an 8 on the top, check to see if 8 goes into the numbers on the bottom, because often it will. That'll help us simplify a little. Over here, x over 2x plus 6. Well, those both have 2's in them, so 2 times x plus 3. So what we want to do then is we want to do a little simplifying first. If we look at this one, notice that those both cancel. We would put excluded values out here. Our excluded values are -3, -8. Oh, and that's it, because we have a -3 there too. So those are our only excluded values. Just good to keep in mind as we do this. We simplified this one, so now it's just 1 over x plus 3. Well, that makes our life a little bit easier, because now that we look for the LCD, we have x plus 3 as one factor. That's all we have over here, because we got rid of the x plus 8. Woohoo! Over here we just have, the only other one is a 2. Again, we're not going to ever have to repeat anything. So a nice thing about this problem is 2x plus 3 is already the denominator here. So this one we don't have to do anything to it. We already have the least common denominator. This one we have to do one more step, and that is take this 2 and multiply that one by 2. So I had to put the 2 on the top and the bottom. I just did that while I had the purple pen open. So 2 times 1 over 2 times x plus 3. Well, that's just 2 over 2 times x plus 3. And then our other expression is still just x over 2 times x plus 3. So we now have common denominators. which is what we were looking for. We haven't changed the value of anything. We canceled out some common terms. We multiplied by the same thing on the top and bottom, so we didn't violate any math laws. We took care of the excluded values, so we would never divide by 0. So everything's good. Thank you very much. I hope that you're having an awesome day, and I will see you soon in class. Ciao.